So a little bit of background on myself. As Bell mentioned, was on the Google Cloud Platform team. I don't come from the media and content side. I come from the cloud technology side. So when Kevin reached out to me earlier this year and asked me to come and join the team as they spun off this business, I was really excited to go onto the buy side of cloud computing and see how things are from the other side. So I joined about 2 months ago. I came from the Google Cloud sales team previously with RightScale. Most of my focus in that world had been on media and entertainment, gaming as well. So I knew a lot of the people in the industry, but it was really exciting to get to join an actual studio that was building a cloud product. So I want to talk a little bit about how Atomic Fiction uses Conductor, and then ultimately how Conductor uses GCP. And to start, I want to talk a little bit about the history of Atomic Fiction. So in 2009, Kevin Bailey and Ryan Tudhope founded Atomic Fiction. They were alumni from IMD, which is a Disney company, or was a Disney company. And they were also at Lucas for quite some time. When they founded the company, they wanted to build a business around new technologies that had just come out. So they were using the cloud. At the time, they were using Zinc Render, as Todd talked about earlier. But as the company grew, and now it's 125 employees, 2 locations, 3 locations, I guess if you count the LA office, the needs of the business changed. And so they decided, as many different studios do, to build their own render pipeline. But they were going to build this render pipeline in the cloud. So enter Conductor. They hired a guy from DreamWorks who had built very large-scale render farms before, and he came in and built out a product on GCP that took advantage of the minute-by-minute billing, the fast boot-up times, the fast shutdown times. They could just simply deploy whatever they needed as far as a render farm was concerned in under a minute. So how does Atomic Fiction use Conductor? We use it for rendering on demand. So submit a job. Artists, as Todd mentioned, artists are expensive. You don't want them sitting there and waiting for any period of time. So once they submit their job, we want to get that back to them as quickly as possible. So especially with high priority jobs, we'll just default map a single frame to a single instance. One of the great things that we love about Google is the sheer size of it. So if we want to deploy 1,000 instances, we can do that in under 10 minutes. We can then run those for maybe 1,000 frame sequence, and then shut those down, with a 10-minute minimum, say 11 minutes later. And then all of this plugs into Shotgun's cloud solution, which is a great product. We love using it. It's we're doing some deeper integrations with Conductor and Shotgun as well that will allow us to feed data back and forth. We're currently pulling data out of Shotgun, but we'd love to push some data back into it around how much does a shot cost to render? How many times have you rendered it, and what is the total cost of that to date? And so a little bit about how Conductor uses GCP and why we love it. So we use Compute Engine for our render farm, as I'm sure most of you know. But the things that we really like about Compute Engine are first and foremost the per minute billing. We were on Amazon through Zinc when they were on Amazon before, and we saw a lot of waste. An average frame for us takes 37 minutes to render using Katana. So if we only run that instance for 37 minutes, we waste the last 23 minutes of that hour. With Google's platform, we're able to run it for just that 37 minutes, shut it down, not worry about it anymore. Next is cloud storage and persistent disk. So we use cloud storage in their nearline archival system to back up used assets, to back up old assets, to store pretty much anything that we upload. And it's become, for Atomic, our single source of truth. And then we use persistent disk with a custom NFS setup, also some Gluster, as you guys have heard today, to do our file serving. It works really well. We have yet to hit a ceiling with it. I'm going to walk through a pretty detailed example of how we've done this on our most recent project. And you'll see that we spike it pretty high a couple of times. So a little bit about Conductor. So Conductor is a new product. It's pre-release. You can go online and sign up to join the private beta. We're happy to have you. You're going to get a phone call from me right after that happens. We designed it with the artists in mind. We've gotten a lot of guidance from the Atomic Fiction team. It's great to have a really tight feedback loop with coming out of a studio. The artists are really the ones that we want to cater to here. So we've built tools to integrate with Nuke, to integrate with Autodesk, or with Maya, to integrate with other products in the industry. V-Ray is another great one. And we just want to integrate it in such a simple way that an artist can build their scene and click render in the cloud. Send it to Conductor. And then we give those artists a really simple UI so they can go in and see if jobs are pending, if they're uploading, if they're completing, maybe view some log files if they want to do some of their own troubleshooting. And then for the render wranglers and the admins out there, we build tools that make the troubleshooting process just that much easier. So we have complex job management tools. You can update priorities on the fly. You can restart, kill, pause, check the status of jobs. You can build automated workflows. So as you start to build priorities and things into, say, Shotgun software, you can make sure that when a job goes to the cloud, that a high priority one drops right into a queue and starts going right away. And then for the finance and operations folks, this is one of the things that we're going to talk about in the next couple of slides. It's an interesting thing. Cloud costs have always been considered really opaque. And a lot of people have been concerned about runaway costs, IT leakage, people launching instances and not shutting them down, people storing stuff and not deleting it, and really dealing with runaway costs. So one of the things that we took really seriously as we started doing this was to focus on how do we want to present that data to the artists, to the administrators, to the finance people. Is it on a daily basis? Is it real time? What we landed on is that we use Google's BigQuery service and data store. So we have all sorts of breadcrumbs in our code to be able to track when instances launch, what shot they were associated with, what they were doing. And we feed all of that data into a huge table that we then can build dashboards around so you can see this show by shot, by artist, and slice that data in a lot of different directions. So I want to talk through a real-world example here because I think that's probably the best way to talk about cloud costs as compared with maybe a more traditional data center approach. So the most recent project that we finished was Bob Zemeckis' The Walk. The Walk is the story of Philippe Petit, who walked between the Twin Towers in the 1970s with no safety equipment, for those of you who have not seen it or heard about it. As you would imagine, this took quite a lot of visual effects time because the New York skyline looks a lot different than it did in 1970. So we had to recreate all of the background, the towers, all of that for 37 minutes worth of visual effects for this movie. So it did take quite a lot of render hours. It took just over 500,000, in fact, which is 87 years worth of rendering time on a single node. This is all done on 16 core instances for our rendering, 32s now that they're out. And we are also doing a lot of our comping now on smaller instances, taking advantage of just the full gamut that Google has to offer. So you can look at our cycle here. So we started off, the months are somewhat arbitrary, but asset creation, poorly optimized renders, that's what that early ramp is. Months 3, 4, and 5 are October, November, December. So that's the holiday dip. People not working for half the month. This year was especially. Everybody had about 2 weeks off. And then you see us ramp way back up into production and peak out there, with quite a lot of render hours in what was March. And then you can see it drops back down to almost zero, and then this new month, it is all the way down to zero for this project. So zooming in on March alone, because that was our big spike month. Over the whole course of the film, we used 9.1 million core hours. We're normalizing some of this data into core hours because we use different instance types and things like that. But in March alone, we used almost 3 million core hours. You can see this is on a day-by-day basis. the breakdown of our render process. So, sort of a normal 2-week cycle. Then you see a big spike as we started getting into the final film reviews with Bob. And then you see one big spike, which was the night before our big film review, where we had to render a whole bunch of shots and scenes and do a whole bunch of comping in that particular case. You see it drops back down. That was the day of the meeting. We got some notes, spikes back up, and then it goes down as we deliver the final project. This is coming from the cloud space for a long time. This is like the perfect use case for cloud. I mean, you could own the infrastructure, but where do you own for? Do you own for the 2 big spikes there in the middle and deal with some delay for the bigger one? Well, that would have meant in our particular case that the shots wouldn't have been ready for their film review at 9 a.m. So the cloud is an obvious choice. So we had a maximum spike to over 1,000 nodes. A couple of interesting stats on that. It took us about 12 minutes to launch all those nodes. That was pretty impressive from my perspective. When I was watching it that evening, watching the number bounce up. And during our sort of common peaks, not just in this month, but in other months as well, we see around 500 nodes. So for sake of evaluation, as we go through some of the cost comparisons here, we actually took it below 500 to 400 nodes to do a cost comparison, because at 500 it was, it just didn't make any sense to buy that many if you're only going to be working on one project. So this is Conductor's cost curve. So this is for Atomic's actual costs. These are actual rack rate bills straight out of our system that we sent to Atomic. You can see that it mimics very similarly that curve that we showed in the previous slide. But you can also see that the monthly loaded cost of supporting 400 nodes, for most of the months there is significantly higher than what they actually would have needed. Now, this doesn't take into account the fact that we were working on other projects at the same time, and there is some overlap there. But if we go back and we analyze, what we need when we need to hit spikes at the same time, when we have production deadlines that overlap, we think that this was a pretty fair estimate of how much we would have had to spend on actual infrastructure. So here are some summary notes on this example. We used 9.1 million core hours, spiked over 1,000 nodes. With local infrastructure, if we had tried to support some of those spikes with some optimizations added, we would have ended up at 30% average utilization. That's a pretty gross number. You don't want to ever see that in a data center, but it's sort of a reality of the fairly cyclical work that we all do. We estimate, by subtracting those 2 previous graphs together or from each other, we saved about $800,000 on this show alone. That's a pretty big number. When we look at the bids, that makes us much more competitive than some of the other studios that are out there offering, similar style visual effects. I mean, a lot of this we have to thank Google for. I mean, billing by the minute, that's amazing. We obviously would not be able to achieve any of these sorts of numbers with hourly billing at Amazon. The hardware is delivered on demand. If you compare this to a 3-year buy cycle, you have to buy hardware and you're not going to be able to get updates on it. Google updates their hardware all the time. So you're constantly getting the latest and greatest, better network performance, better servers. As things start to go obsolete, they're already updating them. And then the global footprint. So we have offices in Montreal that are doing rendering, Montreal and Oakland. So being able to have this happen in the middle of the country where we can do caching between the two with a VIR and allow Google to be our single source of truth that we pull any texture, color, dependency down from to do work on is amazing. And the fact that Google's network is so vast allows that to happen really seamlessly. So I want to wrap up with a little bit of talk on where we see the future of the cloud going. We see further democratization of these resources and easier access. We're seeing through partnerships that Google's forging, that we're forging with some of the vendors in the industry, that there's an appetite to do, cloud-based licensing. So licensing as a service, pay by the hour, pay by the minute, pay by the second in some of our partners' cases. That's something that wasn't there before. So we want to help lower the barrier to entry so that people can get on the cloud and can set these farms up and do their work easier. At least in our case, we already see cost savings. We know through a lot of the discussions that we've had that people have done a whole lot of analysis on this, and they don't think the savings are there. We believe that they are, and we're passing those through to our customers. Or, Atomic Fiction is in their bids. Our bids are very cost competitive and significantly lower than a lot of the competition out there. And it allows us to afford higher quality artists. So the end product ends up being much higher quality. And then in the long run, we do see the entire workflow moving to the cloud. You've already got things like Shotgun that's cloud-based. People are starting to do rendering in the cloud. But as technologies come out for better compression and for things like that, where we could put artist workstations in the cloud, we could put the full render pipeline up there and be able to stream back color-accurate scenes. I mean, all of a sudden, you think about the industry and how many people are moving to Canada and to other areas due to the tax benefits. You'd be able to create a studio on demand and simply give all of these artists Chromebooks or MacBook Airs with big high-def monitors that they can use, and you end up saving a whole lot of money on overhead by being able to do that. So with that, I'm going to be around for the next hour or so. I know that I'm standing between you guys and a delicious Google lunch. So come ask questions. I'm happy to chat. You can find out more information about Conductor by going to renderconductor.com and signing up for our beta. Happy to get in touch and chat with you about what we're doing. And thank you very much.